Okay, let's dive right into this explainer and unpack a seriously critical new global standard for artificial intelligence transparency. Look, as AI systems become so deeply embedded into our daily lives and, our critical infrastructure, securing them, it's just no longer optional. So today, we are going to explore the comprehensive, brand new guidelines released by the G7 Cybersecurity Working Group. We're going to look at exactly how we map out the literal DNA of artificial intelligence.
Here is our quick roadmap for today. We'll start with the AI Transparency Challenge, define the ultimate ingredient list, map out the 7 AI clusters, look at tracking systems and metadata, dive deep into unpacking models and data, and finally wrap up with securing the AI future. Let's get to it.
Starting with Section 1, the AI Transparency Challenge. We really need to talk about the black box problem.
Hooking right into the absolute core of the issue here. AI systems right now act like massive, incredibly complex black boxes. It's kind of like going to the grocery store and buying a mystery can without a label on it, except, this mystery can might be running your company's entire HR department or your logistics network. Without actually knowing what components, what libraries, or what raw data sets are running under the hood, effective vulnerability management and really just basic cybersecurity risk mitigation is practically impossible. Radical transparency isn't just some nice-to-have feature anymore, it's absolutely critical. And to fix that black box, we aren't just looking at a localized, small-scale effort. This is a unified global front. We're talking about a joint publication by the absolute top cybersecurity agencies across the entire G7. You've got France's ANSI, the US's CISA, the UK's NCSC, Japan's NISC, Germany's BSI, Italy's ACN, and Canada's CSE. All of these heavy hitters are teaming up with the EU Commission to create truly actionable, practical guidelines for everyone in the public and private sectors.
Moving to Section 2, the ultimate ingredient list. Let's define what an SBOM for AI actually is.
So let's define our core concept for this explainer: the Software Bill of Materials for AI, or SBOM for AI. We have to start by recognizing that AI systems are, at their very foundation, just incredibly complex software systems. Just like traditional software uses an SBOM to track all its dependencies, an SBOM for AI is a structured record. It's a comprehensive inventory of details and supply chain relationships for every single component used in building that specific AI system. The really crucial point is this exact analogy, which comes straight from the executive summary of the framework itself. We are essentially looking at a highly detailed recipe or an ingredient list for AI. Think about it. You wouldn't buy processed food without checking the ingredients for allergens, right? Well, organizations definitely shouldn't deploy AI without the data they need to track vulnerabilities, spot weaknesses, and ensure their IT security processes are actually effective.
Which brings us to Section 3, the 7 AI clusters. Let's map out this framework. The G7 framework cleverly categorizes this massive recipe into 7 interconnected clusters. You can think of these as the major aisles in our metaphorical grocery store. We've got metadata, models, system-level properties, datasets properties, key performance indicators, infrastructure, and security properties. Now, apart from the metadata cluster, which really just describes the document itself, all of these clusters hold equal weight when it comes to properly securing the AI supply chain. Let's dive in to Section 4, Tracking Systems and Metadata. This is all about top-down documentation.
Okay, so the metadata cluster is basically the fine print on our nutritional label. If you are relying on a security document, you absolutely need to know its provenance. This tracks exactly who wrote the SBOM, the version history, the precise software tool that was used to build it, and crucial details, like whether it was generated before or after the AI's actual build phase.
Now, the G7 framework makes an incredibly important and honestly sometimes overlooked distinction right here. It forces us to delineate between the SBOM author and the system producer. So the SBOM author is the entity generating the documentation and running the tool to create the SBOM. But the system producer, that's the entity that actually creates, defines, and identifies the AI system itself. Sometimes, sure, they're the exact same entity. But very often, an entirely different organization might be generating the security documentation for a third-party AI system.
Moving one layer deeper, we hit system-level properties. This captures the AI as a whole. It's not just about, what databases are being used. It's about mapping out the entire nervous system of data flows and multi-agent communication protocols. And crucially, it forces developers to explicitly declare the intended application area. Because look, a vulnerability in a customer service chatbot is bad, sure,
But a vulnerability in an AI deployed in a hospital or on a financial trading floor, that is catastrophic.
Section 5, Unpacking Models and Data. Now we are getting into the core ingredients.
The models cluster is where we get into the actual DNA sequencing of the AI. It demands fascinating, almost microscopic granularity. You can't just wave your hands and say, oh, we use a language model. No way. You must provide the cryptographic hashes, the digital fingerprints of the weights to guarantee its integrity. You've got to document its exact architecture, exactly how it was trained, like was human feedback or direct preference optimization involved, and you have to strictly define its specific licensing conditions.
What's really fascinating here is the strict, vital distinction the framework makes between system inputs and outputs versus model inputs and outputs. For example, a system might just take in a simple web query and spit out a PDF document. But the underlying model, that requires documenting the specific modality. Is it text, audio, image, video, and the exact type of tokenizer that was used to pre-process and feed that raw data right into the neural network.
And finally, the absolute foundation of it all, dataset's properties. Organizations must unpack the raw ingredients. Where exactly did the data come from? What are the statistical variances? But the real minefield here, the thing that keeps compliance officers up at night, is sensitivity. You absolutely must declare if the training data scraped up personally identifiable information, copyrighted material, or protected medical records. This is a massive legal and compliance blind spot for so many current AI systems. Zooming back out for Section 6, Securing the AI Future. Why does all this actually matter?
Well, these minimum elements represent the fundamental data that organizations desperately need today. Think about it. When a zero-day vulnerability is discovered in some specific machine learning library or tokenizer, an SBOM for AI allows an organization to instantly search their ingredient list to see if they're exposed. It fosters critical vulnerability management, it supports comprehensive cybersecurity risk management, and it provides vital traceability for complex, backported software dependencies across the entire supply chain. So I'll leave you with this provocative thought to chew on. The G7 has basically drawn a line in the sand regarding what transparency looks like from here on out. As AI continues to deeply integrate into our critical infrastructure, our hospitals, and our financial systems, can your organization genuinely afford to deploy an AI system without knowing its exact recipe? The days of the AI black box are definitely numbered. Thank you so much for joining me for this explainer on the G7 SBOM for AI framework. Now it's time to dive into your own systems, start mapping those dependencies, and really take control of your AI supply chain. Catch you next time.